Yeah, hello everyone. Welcome back. Today we gonna solve a hard problem from the daily questions on Leetcode. Uh, Today problem is the upgrade versions of the last day. Of yesterday. It the total characters in string after transformation to. Mm, so there's a little change in the statement from previous problem. Is it is to you need to replace a character with the next known as a consecutive character. Is for example if the character is A and the nums is 3, so the character A transform into next 3 consecutive characters like B, C, D, and if nums is 4, it's gonna be B, C, D, E. Yeah. So transformations wraps around alphabet if it exists these, for example, as E, Y, and nums 24 E, 3 Y transform into the next E, G, A, B. Okay, so it's only have a 26 character and it's like a circle. Yeah, it's the same. The result of this problem is the same as previous, that you need to find the length of the result after the exactly t transformations in the modulo 20 in this modulo. Yeah, 1 billion plus 7 is the prime number. Okay, let's take an example. For example, the example 1 is exactly same as the previous problem. That's the transform to the next character, and the last character transform the last character, that is Z, transform to a B, right? So it's the same problem, but this problem is really a more general persons. That's the maybe which the constraints is the length is the same, but but the T is different. It's a billion. Yeah. Even it's harder. The number steps is really large, and the statement is more general. That we don't move from a character to the next character, but from to next k consecutive character. It's more general. It's really hard. So let's take example 2 to understand the statement. We have these nums that A must transform to B, C, A, B, C, Z to A and B, right? Because Z is the last character in the alphabet. B becomes C, D, and K become L, M. So the string after the post transformations is this at the length is A. Okay. So that if you understand the question, we go into the solution. So okay. So let's take an example like A, B, C, D, E, like 2Z. This is alphabet. Like the nums is like 4, 2, like 1, and 1, like it's 3. For example, we have the nums this. So as the previous the medium versions of these problems, we only have the T is about 1 million, so we can use follow there's iteration. We do iteration and move like this. We move A to B, C, D, like A to B, C, D, right? B, C, D, and like the B is moved to C, D, C to D, and D to E, like this, right? But now we can do iteration anymore because the limit is too large, and we must think to another solution, more general way. The start alphabet is 26, right? 6. And as we know that after each iteration, like for example the first iteration, like the A is gonna become, for example, like become BCD, right? BCD. Can be CD, and the B gonna become CD, like that. As we know that A gonna become B, CD, so let's call the F of C like is use okay, FC's wait a minute. So let's like consider like indicate that FC is the number of character C in the string, right? In the string, in the current string. I don't know if we adverb correct. A current string. So if you have a mode like this, so it's gonna A gonna be 0, right? Because we transform A to another, so A completely go away. So and FB now is plus FA. No, FA is now become FA, right? Okay, we transform A to B, right? A to B, and the same as FC gonna become FH, and like FD become FA, right? So it will like we move to this 3 and become 0, the same as the same to the B gonna move to C and D, and it's gonna be 2 like that, and C become D, like it become 1. Is move, and so we can let me write the string again for more reasonability. ABC, A, B, C, D, E, F to the Z, Y, Z, like that. A, E, 3. So all of this gonna get the accuracy of the character A, and the B is like A, and the B is like to become C and D. So the character C and D gonna increase the exactly amount of B, right? So we can easily we imply that the frequency, like for example, the frequency of C gonna be frequency of A plus B, right? Because A is transformed to BCD, that's contain C, and the B transformed to CD, that's contain C2. So FC gonna become the frequency of A plus the frequency of B, the same as D. How about B? FB gonna become it receive the from A. It is from A, transform from A. And how about 8? Because if A transform to another, so it's gonna be 0. But let's consider the case that Z like Z equal to like 3. So it should transform, because it's circular, then Z gonna transform to next 3 character like is E, B, C, D, right? B, C, D, right? B, C, D, right? So now what about A? A gonna become Z. We assume that like we don't care about y, just for demonstration. And how about b? B now we see from a and also z, right? Z, and the c is the same. We see from the z. That's after an iteration. Our frequencies array is trained like that I described here. As at the previous the problem, the middle version, I said that we don't need to care about the original order of the strings. We only care about the frequencies because we only need to calculate the length, and the transformation is only on the character. We don't care about order, so it's not the original string. We only care about the frequencies array f here. So yeah, as you can see that after iteration, the character a is gonna become the next like 3 characters. So that 3 character gonna increase the occurrences of the a. Yeah, at here. Okay. So you can see. So from the nums array, you can determine that what character gonna increase the numbers of occurrence of the character will be increased from the character that reached that character. So I will write the general formula here, like let's call f e c is the sorry that this must be fc. Yeah, okay, the character, not the variable, but I hope you understand that. So now we write the general computation here from formula right now. Just a minute. Why? We call f is the number of character c, the number character c after iteration. Iteration. I don't know is right. Iteration. Okay, iteration after the fic is the number of characters c after iteration of string. Okay. Now of string s, right, of the original string. So we can calculate fec by the previous iteration. That's the fe minus 1 is the previous iteration of e. That's the e minus 1, and the character h with he, the not is sum, must be sum of fe minus 1, which is the character that can reach c, right? For example, like the c can be reached by a and b, okay, or z, or d, it can be reached by c and b, c and b and a, and no, c and b and a. Okay, and this must have c2, right? B can be reached by a and z, right? I demonstrate here. So I generalize to this formula. Okay. So is look now it's look like a dynamic programming. Is like it's the same as the way you calculate the Fibonacci number. That's the sequence. Is this f is equal to f minus 1 plus f minus 2. It's just the same way at the Fibonacci, right? So it's like dynamic programming solution, but we can use a dynamic programming approach, but it only valid if the limit is small as the previous problem, the medium version. But we have the number of iteration is really large, it's about billion. so we can do it. So as if you don't know, I will tell that we can use a technique here to, if you don't know how to calculate the Fibonacci array, I mean the Fibonacci number, a really large number like 1 billion. What is the billionth element of the Fibonacci sequence? How can you calculate it? We use a technique called magic multiplication, and you can find on some site like algorithm or some sorry, like this. We can see the way to calculate the Fibonacci using magic multiplication. Fibonacci there, here, we can calculate the Fibonacci using magic multiplication. Let me test this. You can go to some page and read about it. I don't know, but you can search more about magic multiplication and get a good example. You can use to calculate Fibonacci or Fibonacci, whatever. That's your magic multiplication. With just O log time complexity with the times with us with space about O1. It's exactly O9. And the time complexity is like the size of magic multiple to the log. Let me put the this. I hope I can copy the image and pass into this sketch app. Okay, it's correct. Okay, I will because it's about math. You can do research after watching this video, this tutorial, but I gonna explain it short for this. As we know that f Fibonacci, I call Fn is like Fn minus 1 plus Fn minus 2, right here, and f minus 1 is like f minus 1 0 plus f minus 2, right? To more clearly, I want to push 1 into to the previous, the factor is the factor. So you can see that the magic we can form here is 1 1 1 0, as I write 1 1 1 0 here, and like 1 multiple by f and minus 1 here, and f minus 2 we got, and fifth minus 1 equals fifth minus 1 is plus 0 plus fifth minus 2. That's why we have this metric. After the multiplication, it's gonna be this, and this with this. So we achieve this. So back to our original problem. Our problem today is the same logic as the magic multiplication of the Fibonacci. We can the state can reach E of the Fibonacci is the previous and the previous of previous. Right? This is E minus 1 and E minus 2, and our problem is the state can reach the C is the H, which character that can reach C from the nums array is totally the same, but another statement and another magic. So you can form a magic like this: F E of the character A, F E of the character B, to F I of character Z, like that. Z it equal to, now what let's take my example. What state can reach A? As we can see, that is Z, right? Is Z. So we gonna like index like A, B to A, B, C, D to Z, like that. And F, E, C, dot. So we can reach the A from Z. Còn how about B? We can reach B from A and Z. Let's see, A and Z. And how about C? C can be reached from B and C and B and A and Z. That's this. On the empty space is you can assume that's 0, but it's gonna waste my time if I fill on. So you can think that it's 0. Okay. How about Z? I don't know. The same. So we can do the same about. Let's take D. D is ABC. It can be reached from ABC. D. Fi here. Fi can be reached. Fid can be reached from A, B, C, and on is 0. 0. Okay. The same for the remaining character. So we can form a matrix now, but we multiple to the previous statement, state. That's F minus E minus 1. This is A, and it's the same to F minus 1 to the Z. So we have like a 26. This is 26. This is a 26. 1. This is 1. And this is 126. The size of the matrix is a matrix multiplication problem. So now our problem is convert from a normal problem to a matrix multiplication problem. As that we form this, and the answers of us will be like is minus 1 is minus n, as we have n t power t, the base matrix power t, as it is t iteration multiple the base, the initial state, that's the f0 and f0 A to f0 Z. The f0 state is the state of the original string, that is the frequencies on the character of the original string. Okay, so far we have this the matrix multiplication. Now let's dive into the implement station. If you don't understand anything, just comment and ask me out. Okay, so we need to do the matrix multiplication. So and to save our time, I have implemented it before here using my my template. This is my template. You can copy it. You can search for matrix multiplication course on anywhere on the internet. But you can implement it yourself. But to save time, I'm gonna copy the code here. Okay, if you don't know about matrix multiplication, just learn it. It's about linear mathematics. That we have it here. So we're gonna about create this the base. We call it this base, the base matrix. Matrix base. This thing like that. We have this alphabet character have 26 character. So we use the 26 matrix. Okay. Now let's create the array for Z from the E plus 1 to nums E plus num E. Like you can see that if A3 you can reach B, C, D, that's E from A plus 1 to A plus 3. So this base here E, G, and I is equal to 1. right? You can know that the B, the ZI mean like for A you have B, B1 and C1, D1, okay? And now we need to do create the initial when this type to be 1 and sig 1. It is the frequencies of original array. So just do a single for loop here and do init and a of s minus a 0 because we count the frequencies of the at each character. So now we create this result matrix is, as I said before, the result should be the base power number of iteration multiple to the initial matrix, and the answer is gonna add after this multiplication. We have the fn a, fn b to the fn z is the frequencies of each character in the final string after t iteration, and all we need to do is sum it, to sum on of it, sum on these 26 character. That's this result a e and 0 module sum. We model it to 26 because it's circular. Okay. Okay, so has not is you can see that the just skip the implementation of the matrix multiplication. You can see that our solution is very short, even shorter than previous easy medium version. Okay, goodbye.